Yes, we are live. Okay, hello. Welcome back. So I'm glad that you are all still here on a Sunday, and there's been some really great talks so far. I've been watching all day, so I hope that you like mine. I'm here to talk about the vulnerabilities that hide from your tools, and I'll start by introducing myself. My name is Jillian. I am the founder of Gold Hat Security. I do application security training for developers. I've spent a little over 11 years working in AppSec in various forms, but my favorite hat to wear, so to speak, has always been training. So that's why I called it Gold Hat Security. And I got my gold hat on. I don't know if you can see, I'm kind of small at the top. But anyway, I love to tell jokes, and when we could still travel, I really do enjoy traveling. So that is a picture of me in Bali with a baby elephant. So let's get started. Wanted to start you off with just a really quick history lesson of AppSec tools, just for context, since we're talking about tools and what they can and can't do. So we'll start with static analysis. So static analysis started out before I was born, and with lint. And I don't know if you guys are seeing the same delay that I am, but it's a little slow. Sorry, but could be just my second screen is delayed. But anyway, I started back in the day with lint, which was not really designed for security, because that was before we even knew that SQL injection was a thing, or something like cross-site scripting. So we got some more tools that started to check for security vulnerabilities using static analysis, like Coverity and Fortify, which I have seen mentioned in the comments. And Checkmarx and Veracode came along later. And this is not an endorsement, or it's also not an endorsement of these tools. It's just some of the highlights. Then dynamic analysis started around late 90s with Nessus, and then got things like Metasploit, lots of fun, Burp, and Acunetics. So dynamic analysis works a little differently, but is trying to check for the same sorts of security vulnerabilities in your web applications. Oh, and also worth mentioning is OWASP Zap. That's my favorite free tool. And then we have open source analysis, or CSA, but Black Duck and White Source. And SNCC, or Sneak. I think I've been saying it wrong all these years. I've heard it both ways. Oh, sorry. Let me zoom back in. Also worth mentioning is IAST, or interactive application security testing. I have not had the privilege of using any of these tools, though, so I'm not really going to talk about that. Anyway, moving right along. We're going to talk about what today's tools are good at finding. So I have a little Venn diagram here, because I like Venn diagrams, between static application security testing and dynamic application security testing. So static application security testing, or SAST for short, is pretty good at finding weak crypto and hashing with an asterisk, sort of. It tries. Find things like hard-coded keys and passwords, memory leaks. They're both pretty good at finding the OWASP top 10. Dynamic testing, pretty good at finding poor session management, missing security headers, default passwords, and insecure server configuration. So that's what they're good at finding, which is pretty good coverage, but we're here to talk about what they're not so good at finding. So let's move right along. What they're not good at finding is kind of a lot. I have a lot of subtopics here, and we'll just dig into each one. First off, let's talk about business logic flaws. So a few examples that I can give you of business logic flaws that your tools just probably aren't going to find. Bad password reset logic. So that is often a security weakness that attackers will use. But if you have poor password reset logic, like security questions are that's probably one of my biggest pet peeves, is those security questions that you can figure out just from looking at someone's social media without verifying without sending a password reset link to their email address. There's really no verification there, so just don't use those. Poorly designed role-based access control also counts as a business logic flaw. So a lot of applications might have just two tiers, admin and not admin, and that's not really great role-based access control. And also worth mentioning, developers with copies of production data on their laptops. I mean, I don't personally, I can't tell you where I've seen that. We'll put it that way. But I've seen it, and it's not good. So that's a thing that your tools are not going to find, but it's part of business logic. So with these types of flaws, what you want to do is really kind of get in there and figure out how things are working, talk to people. Yeah, just don't rely on the tools for this one. So moving on, weak or reused passwords. So fun fact, 75% of internet users admit to reusing passwords across multiple accounts. And those are the ones who admit to it. So there's probably more that don't admit to it. That's a lot. And that's something that your tools aren't going to find either. So configuration whoopsies. So for example, an overly privileged IAM role. I believe the Capital One data breach was caused in part by an overly privileged IAM role. So that was kind of a high profile one. And then default security groups in AWS, when you set up security groups by default, they're wide open. That's not really something that most tools are going to find right away, depending on your tools. But let's see. Denial of service vulnerabilities, and rightfully so. Most pen testers don't test for denial of service vulnerabilities, and most tools aren't going to test for it because they don't want to break stuff. But there's lots of different ways this can happen. So poor error handling, infinite loops, any sort of resource exhaustion, data destruction or corruption, single points of failure, user lockout, and deadlocks. So lots of things can go wrong at the application level to cause a denial of service, and your tools may or may not pick up on them. So are you paranoid yet? I have more. Rogue developers, something else to keep in mind. So something that was in the news in November was that there were 3 Twitter employees who were charged criminally for spying for Saudi Arabia. They were looking at private Twitter profiles to see who was criticizing the government. Now, it's just an example, but something that you should consider as an AppSec person is what happens if a nation state sends someone to write code for you. There have been examples, and I've heard rumors of things like this happening. So it's just something to consider. If that doesn't bother you, great, don't worry about it. But if it does, we'll get into it. But that's why role-based access control is super important, and we'll talk a little bit about background checks. But next up, cryptography disasters. So there's so many things that can go wrong with cryptography, and that's another talk. But just briefly highlighting some of the things that I've seen in my 11 years in AppSec. Any sort of custom crypto, we all know, don't write your own crypto. And then ECB mode in symmetric encryption is really bad. And I've noticed that static analysis tools don't pick up on that necessarily. The talk earlier about modifying your static analysis tools, you can modify it to look for ECB, and I've done that. So highly recommend. Reusing initialization vectors. I've seen a lot of even hard-coded initialization vectors, and that's no good. And lastly, just thinking base 64 is encryption. I've seen that in code more than I care to admit. So these are things that your static analysis tools probably won't find. They might pick up on some of them, but maybe not. So also layer 8 vulnerabilities. And by layer 8, I mean humans, of course. But for example, phishing, social engineering, good old-fashioned user errors, malicious insiders, which we talked a little bit about, but you also want to consider your users, and lost laptops. So maybe there's lots of code on a lost laptop. Maybe there's a copy of the production database on a lost laptop. All sorts of things to keep you up at night. Sorry. But also, secrets in strange places. And this is probably one of the hardest ones to track down because they're in strange places. So, for example, the payload of a JWT, not encrypted usually. I've seen a lot of secrets in there. Any text files or configuration files, sticky notes, which is kind of outside the realm of AppSec, but something to consider. So, also, false negatives. So, for example, we talked a little bit about static analysis tools earlier, but they have a lot of rules that are written to find variables in English. And they'll look for things like password or key instead of like contraseña, which is in Spanish. So something to consider if you have developers around the world is their variable names might not be in English. They probably aren't. And so you might be hiding, there might be some hidden vulnerabilities there that the SAS tools ordinarily would pick up on, but don't because they're written in English. So, but again, the importance of modifying rules as you find these things. So, sensitive data leakage, and I love that word. It's such a funny word, but talking about data, not side effects. Anyway, but for example, anything in an error message, secrets in a URL, log files. I've also seen spreadsheets. Where else can people hide things? Like it's just there's data leakage all over the place. And also, I think I talk about this later, but calling a third-party service and then returning the raw request to the end user. Sometimes a lot of data loss in there as well. So it's a hard thing to find using automated tools. Insecure APIs. And I think the tools are starting to catch up with this a little bit, but still a lot of dynamic testing is not really geared towards testing for API insecurity. So things like API endpoints that probably should have authentication and authorization, but it doesn't. That's something to find. That's something that's really hard to find automatically. Unmanaged, aka old APIs, the kind of APIs that were written maybe 10 years ago in SOAP. Nobody knows how they work. That in and of itself is a vulnerability because nobody's maintaining it anymore. Weak API keys, or not validating them or not validating them properly. And again, like this could be a whole nother talk about things that could go wrong with APIs, but just some highlights, things to think about. Third-party integration flaws, and that was the bullet point I got ahead of myself on. But poorly implemented OAuth is definitely a security vulnerability and something that requires a lot of very careful attention, but probably your static analysis tools or dynamic analysis tools aren't going to pick up on. Any unencrypted connections to those third-party services often aren't found because it's behind what you're testing dynamically. And if the static analysis tool doesn't know if the connection is encrypted, it may or may not tell you about it. But also returning the raw response to the end user is often a security vulnerability. So that's, oh, sorry, that was supposed to show everything. But anyway, the point is there's a lot of security vulnerabilities. Let's see, zoom back in. There we go. All right, so a lot of different vulnerability types to think about, and the point here is that you don't want to rely just on your tools. So back out. All right, so how to find them the hard way. So pen testing, of course. Got Mr. Robot Hacker Man, or of course code review. And I hope you appreciate this graphic because that's the face that I make when I do code review often. Just what nonsense is this? So these are both really time-consuming ways of finding vulnerabilities, and they're effective, but with limited resources, you may not be able to dedicate as much time as you want to them. So now, how to find them the easier way. So first off, we're going to talk about what I call the Lord Varus approach. So Lord Varus, for those of you who didn't watch Game of Thrones, had little birds everywhere who would tell him things. So the idea here is that you want to recruit spies within your organization, or better yet, have an internal bug bounty. So you want to get your developers and everyone in line and thinking about security and looking for security bugs. So that offloads a lot of the work of finding vulnerabilities to the people who are actually more familiar with the code. And so they're going to find better bugs. So I have, again, it's a whole nother talk about setting up an internal bug bounty. If you're interested, I do have a free ebook for you. You can scan the QR code, or it's been to the top of my Twitter profile. But the point here is, setting up an internal bug bounty is going to make your life a lot easier. And what you want to do is make it fun for people to come talk to you. So instead of people being scared of the security people, they'll actually bring you vulnerabilities. And there's a lot of different ways to do this, and you don't have to spend a lot of money on it, which is the nice thing. You could just reward people with food, with donuts or pizza, and that's actually pretty effective because everybody likes food. It might be a little bit hard to do with everybody working from home, but actually, yeah, probably pretty hard to do. I think you can order Domino's online and have it delivered to somebody's house, but anyway. What else was I going to say about that? But the point here is that you want to make it fun, and you can also reward people for fixing vulnerabilities, which is the ultimate goal. So at my last job, I actually had like a scorecard, and I was tracking how many vulnerabilities each team fixed, and whoever fixed the most in the month got some kind of recognition. And it was actually really fun because it started to use competition as a motivation to fix security issues. So just a few ideas for you. Check out the ebook if you want, or just tweet at me if you have questions. I have lots of ideas on that one. So that's the Lord Varus approach to security. Also, threat modeling. And this is something that I could also go into a lot more detail about, but I'm guessing that most of you are AppSec people and you don't need to start from the beginning. But I have one major tip for you with threat modeling, and it is the art of asking the open-ended question. So instead of, is this connection encrypted? So you get in a room with all your developers and architects, and you got your architecture diagram out, and you ask them a yes or no question, they're going to tell you the right answer pretty much all the time because they know what the right answer is. But if you ask them, how is this connection secured, and they don't know, that's a sign that that's something to dig into a little bit more. So that's my favorite technique. You can also ask them things like, where is the encryption key stored? And if they don't know, signs of trouble. Or for another example, instead of, do you have any sensitive information in this database? They're going to say no, right? But you could ask them, what data is stored here? Or can you email me the schema? Which takes a little time to review, but that's just a better approach to threat modeling. And I hope that helps. So, yeah, so that's my threat modeling tip. Now, last up, and the previous talk, Frank talked about this quite a bit about integration tests. So I just called this the full circle development life cycle. You want to use all the feedback from your tools and pen testing and threat modeling and maybe even internal bug bounties to create your automated test. So instead of found a new bug, yay, fix the bug. And then a lot of us stop there. You don't want to stop there. So write a new test case and then write some new code and deploy the new code and then found a new bug and just rinse and repeat until your automated tests are doing all of your work for you. Yeah. All right. And then last category is preventative care. So once you have done all of the previous steps, actually, you could do this first. There's no really reason why it couldn't come first. Sorry, I haven't had enough coffee, I think. I woke up early on a Sunday, and so my brain is still a little sleepy. But anyway, so preventative care. First off, education. So this is something that I am very passionate about because I love teaching. So I can give you lots of ideas or even do it for you. But the point here is that you want to make it fun. So security is often seen as, you know, a roadblock or a pain in the butt or scary or grumpy. So you want to make security fun for people, and then they will start to, for one thing, they'll pay better attention in class if you make it fun. And for another thing, I've found that a sense of humor helps you remember things better. So I took Spanish in high school, and I love telling the story. So my Spanish teacher called herself La Bruja, which is the witch. She was actually really sweet. But I will never forget this. She would always make a joke about problema, because problem is problema, but it's masculine. It's el problema. And so she would always tell me, or tell the class, you know, she would be writing on the board and she'd say la problema and then erase it and say el problema. She's problems are masculine. I know all of mine are. And that joke has stuck with me for like forever. And so it's el problema. Problemas are masculine. And just using a sense of humor helps people remember things better. Simple as that. So anywho, also spread it out. I have tried it. I've tried it both ways. So when you have people in a classroom for 8 hours a day, learning what for a lot of them is brand new information, they're only going to absorb about 3 hours of it. And then the other 5 hours are probably lost. So they're like, they might be trying, but just there's only so much new information you can soak in a day. So I would say like a maximum of 4 hours per day in the classroom for your developers. Or better yet, just, you know, send them an email once a week with, hey, this week we're learning about cross-site scripting, and just breaking it down into small chunks helps people remember and learn better. And then also make sure that your training is teaching to more than just the OWASP top 10, because there's definitely more than 10 vulnerabilities. Just that's my education spiel. I hope that helps. Also, secure default configurations. And this could be a whole nother talk also. Maybe I'll do that someday. But you want to use template configurations like Terraform or CloudFormation to make it easy for developers to set up environments. Now, if your developers are not setting up their own environments, awesome, don't have to worry about it. But if they are, you want to make it really easy for them to spin up a test environment that is secure and doesn't have wide open security rules. So making it easy for them will really help you a lot. And background checks. So we talked a little bit about rogue developers or just even rogue employees. And one thing I have noticed with a lot of just companies in general is their background check tends to be limited to a criminal history and credit score. And if you can work with your HR department or recruiting company to make sure that those background checks are more comprehensive, that will go a long way to prevent the kind of things like nation state actors working for you and writing backdoors into your code. So if you're working with a tech recruiting company, for example, ask them what their background check process is. And for God's sake, check references. So I surprising amount of hiring managers don't check references. So just check references. And if they don't have any references, that's a warning sign. So anyway, that's that. So I've gotten through this a little faster than I planned on, so I can take some questions. Let me scroll back and see what you guys have said. Hold on 1 minute. Do we have any questions? Oh, okay. Have you used the ASVS checklist in your testing process? Any tips for making checklist fun? I am not familiar with that particular checklist, but let's see. Tips for making checklist fun. That's a great question. I know what works on me is stickers. I've never outgrown stickers, but I don't know, just like a square paper graph with little stickers when I get something done. That's actually still effective, and I'm not a child anymore. Let's see. Nothing else is coming to mind right at this moment, but I'll think about it, and I can tweet at you. Ray's working on an internal bug bounty. That's awesome. More detail on internal bug bounties. Sure. Okay, so there's kind of a lot of prerequisites to setting up an internal bug bounty, just like with an external one. And I would highly recommend that you do an internal bug bounty before you start your external one, because that'll get all the processes in place for when you have an external bug bounty. But the first step, obviously, is getting executive support, and vocal support is one of the things that I like to tell people. So whatever your bosses are seen and heard talking about becomes the top priority. Even if they tell you, yes, we definitely support security, we want to back you up. Sure. If they tell you that in a meeting, it doesn't have quite the same impact as if they go and talk to their developers, the product managers and such, and say, security is just as important as new features. And if you can convince them to say that, good on you. But I have some tips for talking to executives. And like I say, like that's a whole nother talk, but talking to executives, you want to remember that they're busy and be very respectful of their time, and be sure that whenever you're talking to your bosses, you end every conversation with this phrase: "Thank you for your time." And that will go a long way to helping you gain some rapport with them. And also, the art of speaking about security from a business perspective takes practice, but that will be very effective in winning over your bosses. And then also, my most important tip is always have an answer to the question, how long is this going to take and how much is this going to cost? So those are two things that executives are always going to want to know, and you should always just have the answer to that question ahead of time. And then once you get executive support for your bug bounty, then you need to set up a process to organize all the vulnerabilities in one place, most likely your ticketing system. And once it's all organized into one place, then you can move on to the next step, which is getting SLAs, or service level agreements, with the development teams. So depending on how severe the vulnerability is, you want to make sure that they're going to fix it within a certain period of time. That's your next step. And then the promoting the internal bug bounty and education is, again, a really important piece of this, because people can't find security bugs if they don't know what they're looking for. So that's all a part of the process, is teaching the developers what sort of security things to look out for. And then if they get rewarded for finding the bug, or they get rewarded for fixing the bug, then that further reinforces the education, because they're actually putting it into very practical use and getting rewards for it. So I hope that helps. not totally sure if you answered your question, but it was a great open-ended question. Good job on that. Let's see. Application security verification standard. Oh, yes, I have not used it. No. So how do you recommend training encouraging experienced developers to include security as part of their code review process without it being a big, scary security review? That's a great question. So yes, your more experienced developers probably know more about security already, so that's great. I think the security champions process is a nice way of gaining recognition, and it's another bullet point that developers can put on their resume is, oh, I was a security champion. So I would recommend like taking those senior developers who are the leaders and either training them up or having maybe a hackathon or a capture the flag event or something fun. Capture the flag, that's always fun, right? So but take those security champions, have a fun day with pizza, maybe beer if that's okay at your company, and just have a fun hackathon day. And then I guess also make it part of the checklist, but that goes back to the question about how to make checklists fun, and I don't know. I think checklists are fun anyway, but I'm weird. So yeah, I hope that helps. I see if I can come up with some more ideas, but make it official. Give them a badge. Security champion around here. Okay, so for things tools cannot detect, like structural design issues that lead to security vulns. Okay, let me try that again. For things the tool cannot detect, like structural design issues that lead to security vulns. I'm not sure what your question is. Try it again. Well, let's see. Oh, yes, or a t-shirt. T-shirts are fun. Or hoodies. But I know we're trying to get past the stereotype that hackers wear hoodies, but I like hoodies. Oh, it was addendum to previous question. Sorry. Yeah. So for structural design issues, I think the best way to find them is just by threat modeling and doing an architecture review with the threat model together. Yeah, hope that helps.